Hi, this is Mr. Urrego, and today we're solving quadratic equations using square roots. I'm going to use the first problem here with the square roots. The quadratic equation, which is x squared equals 144. I'm going to bring that problem here, 144, and we're going to solve it. Whenever we're doing solving quadratic equations, and specifically when we're doing with square roots or radicals, we need to have the x squared. Whatever has the x squared, it has to be by itself, which in this case the x squared is by itself. So in this case I'm going to use square roots on both sides. When we're doing square roots on both sides, technically what we have is plus or minus 144. Okay? Now the radical or the square root is going to cancel the square of the x. So I'm going to have an x here. In this side, I have square root 144, and that's a perfect square. It's 12 times 12. So I'm going to solve that, plus or minus 12. Because I have a plus or minus, I'm going to have two answers. One answer is going to be with a positive 12, and the other answer will be with the negative 12. And these are your answers. Let's solve another one. Let's do 48. 2x squared equals 400. Let's use another window for that. And it's going to be 2x squared equals 400. Like I said before, the x squared has to be by itself before we can do the square roots on both sides. So I need to get rid of that too. That 2 is multiplying the x squared, so I have to divide by 2 on both sides. Okay, this 2 divided by 2 is going to turn into 1, so technically I have 1x squared. In the other side, I'm going to have 200. This one, you can write it or not write it, one of the two, but you know that there's a 1 in there. Now, the x squared is by itself already. So now I can apply the square roots on both sides. And like I said before, this square root is going to cancel the exponent for the x. So I'm going to have x over here. And now, as soon as I do square roots on an equation, excuse me, I have a plus or minus right away as part of my answer, because I'm going to have two answers. Okay, now I have square root of 200. I need to take whatever I can out of that radical. So right now I need to break the 200. The 200, and let me try to do this too again. The 200, you can break it into 100 times 2. Okay, 100 is a perfect square. So if you see the perfect square right there, you don't need to break it again. If you don't see it, what I'm saying right now is the square root of 100 is 10. But if you don't see this, just keep breaking the number. What I'm going to do is, I'm going to keep breaking the 100. 100 is 10 times 10. Okay? And whenever we're doing radicals, remember, that 200 is inside the radical like we have over here on the left. Basically, every branch has a radical. Okay? I said before, for every two numbers that are inside the radical, one is going to come out of the radical. So I have here plus or minus. I said I have two tens inside the radical, so one is coming out of the radical. What do I have left? This square root of 2 on the right side. Because there's only one 2 inside the radical, is going to remain inside the radical. So my answer is x equals plus or minus 10 square root of 2. Remember, I have two answers, okay, because I have one with a plus and one with a minus. So my two answers are the following. I take x and I use the positive sign, so I'm going to be plus 10 if you want to use the plus there, square root of 2. My second answer will be using the negative, negative 10 square root 2. And those are your two answers for the problem. Again, just a quick thing over here. Whenever you're doing or solving equations, the way you know how many answers are you going to get at the end is by looking at the exponent from your function or your equation in this case. The exponent is 2. That means at the end you're going to have 2 answers. Okay? Alright, review please. Oh, I think I'm going to do one more. Hold on. Actually, let's do a couple more. Let's solve this 50. I know many people are going to like that 50 and they're going to be confused about that 9 dividing right there. So let's solve that one. So it's going to be x squared minus 1 equals 5. X squared, so 50. X squared over 9 minus 1 equals 5. Again, we need to leave the x squared by itself. Okay, so now pretend, and this is just pretending, that I'm going to erase that square. So treat this problem like a regular equation. Okay, as a regular equation, the first thing you do is you would just get rid of the negative 1. Whatever is adding, subtracting, that's the first thing you cancel. And then your last step will be whatever is add, dividing, or multiplying. Okay, so let me go back. X squared, I'm just said that so you think as a regular equation. So I have x squared over 9 minus 1 equals 5. To isolate the x squared, I need to add 1 at both sides of the equation. Remember, both sides. Whatever you do on one side of the equation, you're doing the other side. So I'm going to have x squared over 9, negative 1 plus 1, 0. 5 plus 1 equals 6. The x squared is not by itself yet. Okay, it's not by itself. I need to get rid of that 9. Okay, this 9 is dividing. This 9 is dividing the x squared, right? Is dividing the x squared. Because it's dividing the x squared, the opposite would be you have to multiply. Whatever you do on one side, you do on the other side. Now, the reason I multiply is because now this 9 will cancel with this 9, and my x squared will be by itself. 6 times 9 is 54. As you can see, now the x squared is by itself. Here, at this point, I do apply the square roots. Remember, the square root will cancel the square, so I'm going to have the x by itself. And as soon as I do square root on both sides, I'm going to have a plus or minus right away in the other side. Okay? As soon as I do square roots, I will get a plus or minus right away. So now I'll just bring down the 50, square root of 54. Why do we do that? With the square root of 54, we need to break it. So we're going to work on this side. 54 is the same as 27 times 2. I think, right? 27, 9 times 3. Oh, look at that 9. It's 3 times 3. Okay, so let's go back. So we have x equals plus or minus. Let's see what's coming out of the radical. I have 2 3's. So 1, it's coming out. Only 1 3, not coming out. Only 1 2, not coming out. So that means I have 1 square root 3 and 1 square root 2. Okay? Because there's only 1 3 inside the radical. Only 1 3. And there's only 1 2 inside the radical. Neither one of those two values are coming out. So because I have that, then I just multiply back, and that will be my answer. Please, at the end, always break that into 2 separate answers. My first answer is with the plus, so it's going to be 3 square root of 6. The second answer will be using the negative. Negative 3 square root of 6. And those two are your answers for this problem. Now we're going to solve, I guess, 49. Let's solve 49. So it's negative 4x plus 2 equals negative 20. So let's go to a different page. Negative 4 x plus 2, let's see, I went too far. Negative 4 x plus 2 equals, and let me double check that, negative 20. Yes, negative 4 x plus 2 to the second power equals negative 20. Okay, now I'm going to solve that. Okay, here instead of having an x to the second power, I have an x plus 2 to the second power. Alright, that was ugly. Now, before we had only the x to the second power. Now we have a whole parenthesis to the second power. Basically, we think the same way. We need to leave the parenthesis that is to the second power by itself. Okay, this is what we need to leave by itself. Okay, so let's use the same process that we did already in the previous problems. We need to isolate this whole parenthesis because the parenthesis has the power. Okay, so this negative 4 is multiplying. There's nothing between the 4 and the parenthesis. There's nothing here. That means it's multiplying. It's multiplication. Because it's multiplication, then the opposite will be dividing. I divide by the same number on both sides of the equation. Negative 4 divided by negative 4 is 1. That 1 is going to be in front of the parenthesis. Okay? Negative 20 divided by negative 4 is positive 5. Now, this 1, you can write it or not. Okay? Normally, we don't need to write it down. Now, my parenthesis by itself. At this point is where I apply the square roots on both sides. I know that that square root is going to cancel the squares. I'm going to have left x plus 2. Remember, as soon as I do square roots, I have a plus and a minus. Now, square root of 5. Can I take something out of it? No, because that 5 is a prime number, and there's only one number, so I'm not taking anything out of it. So that means I have to keep going and isolate my x. To isolate my x, I need to cancel that positive 2. How? This positive 2, do I do the opposite? Minus 2 on both sides. I bring down my x. 2 minus 2 is 0. Here, I have negative 2 plus minus square root of 5. I'm not able to combine that negative 2 with the radical, because the negative 2 doesn't have a radical 5. So I cannot combine those two. Because I cannot combine them, normally what I do is I push back this plus or minus square root of 5 so people don't get confused. And I rewrite the negative 2 in front. So you're going to have negative 2 plus or minus square root of 5. From here, you want to break into your two answers. My first answer will be negative 2, and I'm going to use the plus first. Plus square root of 5. The second answer will be same negative 2, but now I'm going to use the negative square root of 5. And those are your final two answers. To finish, let's do this 53. Okay? And the reason I'm doing that 53 is because you have a fraction in front of the parentheses. So 1/3 x minus 4 equals 3. 1/3 x minus 4 equals 3. And that parenthesis to the second power. Let's double check. 1/3 x minus 4 equals 3. 1/3 x minus 4 to the second equals 3. And we are right. Okay. Same process. I want to leave the parenthesis by itself. Okay. That means this third has to go away somehow. How? That third is, as you can see, there's nothing between the third and the parenthesis. That means it's multiplication. I do either the opposite, which is divided by 1/3, okay, which will cancel those out, okay, but again, 3 divided by 1/3 is not really too clear for most people. So there's one more way how to solve this. When you have a fraction that is multiplying, you can use the reciprocal of that fraction. You have a 1/3 and you want to cancel it, so the reciprocal is the opposite. You flip the fraction. It's 3/1. So in my case, the reciprocal of this fraction is going to be 3/1. Whatever I do on one side, I do in the other side. Okay? Now, those two fractions, I'm going to explain why does the reciprocal cancel that out. When you multiply fractions, you multiply straight, top with top, bottom with bottom. 1 times 3 is going to be 3. I'm sorry here. I'm making a mess. So I'm using the numerators. 1 times 3 is 3. The bottom, 3 times 1 is 3. But we know that 3 divided by 3 is 1. So basically, when you do reciprocal, these two fractions are going to cancel out. Okay? Let's erase over here. And now, let's continue. So now I know that those two fractions are going to cancel out. And I'm going to have my parentheses to the second power. On the other side, 3 times 3 is 9/1, which is the same value. Parentheses by itself now. Next step, radical, square root on both sides. The square root will cancel the square, so I'm going to have x minus 4 equals, and remember, plus or minus square root of 9. Okay? In this case, can I do square root of 9? Yes, 9 is a perfect square, so square root of 9 is 3. So I'm going to have x minus 4 equals plus or minus 3. Let's keep going. I need to leave the x by itself, so that 4 has to be cancelled. How can I cancel the 4? It's negative, so I have to add on both sides. Here, negative 4 plus 4 is 0. I'm going to bring the x down. Now, there's a common mistake here. Most people will do this. 3 plus 4, 7. So they'll put plus or minus 7. That's a no-no. You can't do that. How come? Because if you see, your 3 has two signs. Oh, I'm sorry, erase. Your 3 has two signs, positive, negative. The 4 has only one, so you can't combine those two that easy. What you're going to do is, whenever you have a plus or minus, push it to the end. Plus or minus 3, and this 4, you put in the front. Okay? Now, it's time to break it into two different answers. Two different answers. So you're going to have, your first answer is 4, and we're going to use the positive part of the 3. 4 plus 3. Can we do that? Of course we can solve that. So my first answer is a 7. Next one. X equals 4 minus 3, right? If on the first answer I use the positive, on the second answer I will use the negative. Okay? Remember, 1 plus, 1 minus. Now, how much is 4 minus 3? 1. That's right. So these are the two answers from your quadratic equation.